In this slide, we are going to talk about semaphores in Pthreads. Semaphore is not part of a Pthreads standard library, so it belongs to POSIX SEM extension, which means for some operating systems, they may only support a Pthread. The semaphores may not be supported. Fortunately, so both Pthreads and the semaphores are supported by Linux system. There are two types of semaphores, named and unnamed semaphore. So for named semaphore, it can be used among different unrelated processes to achieve process synchronization. On the other hand, unnamed semaphore can only be used among different threads, and those threads must be within the same process. So that is the difference between named and unnamed semaphore. Then let's look at the rough version of an example to see how to use a semaphore. At the very beginning, we need to include the semaphore.h header file. So since the semaphore is not included in the pthread standard header file, then we declare a special type of a variable with semt type to hold the semaphore. Then we need to initialize the semaphore with the function seminit function. This initial function will take three parameters. The first parameter is the address of the semaphore variable. The last parameter is the initial value of the semaphore. So since the semaphore can either be binary semaphore or counting semaphore, so which one you want to use can be decided by the value you passed into it. So if you passed 1 to it, it means you want to use a binary semaphore because the value of the semaphore can either be 0 or 1. You can also pass any integer as large as you want into this function, and the range of the semaphore is from 0 to the integer number you just passed into it. The second parameter can indicate which type of semaphore you want to use. So in this case, 0 means unnamed semaphore that can only be used among different threads within the same process. So surely you can pass other parameters to use a named semaphore, but I won't go through the details for that since we are talking about the semaphore in Pthreads. If you want to know more about the named semaphore, you may refer the named semaphore library online. After we prepare the semaphore, we will try to get the semaphore with sem_wait function, which is very similar to pthread mutex lock function. If you cannot get the semaphore, the current thread will be put into the waiting queue until the semaphore is available. If you get the semaphore successfully, so you can access the critical section to make a progress. So right after you exit the critical section, you need to release the semaphore with sem post function so that other threads can have a chance to get it. For initial wait and post function, all of them will return a value back to the current thread. If the function can finish the task successfully, 0 will be returned. Otherwise, a non-zero will be returned. And also, we have another function which is very similar to sem_wait function, which is called sem_try_wait function. It will return the value back to thread immediately so that we can use it to implement busy waiting. It's just like what we did for try lock in mutex lock.